Okay, welcome to Unit 3, Lesson 3, Newton's second law, and this is the second example of the lesson. And really, this is the first lesson where we're going to be doing some math with Newton's second law. So I mentioned it in the first video, but to repeat, Newton's second law states that if an object is experiencing an unbalanced force, then the object will accelerate in the direction that the force is stronger in. So this example will show fairly clearly there's going to be two forces acting on this object. One force is stronger and it's going to be moving in that direction. All right, so let us jump into a little bit of math here. This block, 15 kilos, it's being pushed to the right with one force of 48 newtons, but we see, given in the question, that this block is accelerating to the left. And so the question lets us know that there is indeed a second force acting on this object. We just have to figure out how big that force is. So let me put on here a line, and we'll call this force 2 is equal to something. I drew it in the left direction. We know that it's in the left direction because this object is accelerating to the left. Right? There has to be something larger to the left, pushing it that way to overcome this 48 newtons to the right. Okay, so where do we begin on this? Well, we can just start with a net force formula, right? We have acceleration, we have mass, so let's figure out what the net force on this block is, and then we can take the difference between that to figure out what F2 is. Cool. So starting with F net is equal to mass times acceleration. We're figuring out the whole net force on this block. And the whole net force on this block is equal to its mass and acceleration. So this block weighs 15 kilos. And its acceleration is 1.8 meters per second squared. Okay. Well, if we punch that into our calculators, we get a value of 27 newtons. Now, I didn't really set up any convention yet, but I'm going to say that this is 27 newtons to the left. And why that's important is because, well, you see we have left and right directions, and we've been talking about this for quite a while. We should probably add something on here saying that one direction is positive, one direction is negative. So I'm going to make the right positive like I almost always do. Left can be negative. And let us make this then, F net, since it is to the left, is going to be negative 27 newtons. Alright, and that would be forward, or to the right. So negative 27 right. Okay, we now have net force. Our net force is pushing this to the left with 27 newtons. The next step, we're still going to use our F net formula, but we're going to use the other older one that we've been using for a while now. So maybe let's switch our colors up here. Go into magenta. And we'll say that F net, right, what we just solved, is equal to the sum of the forces. So it's equal to force 1 plus force 2. Well, we have this value. We just solved it. We have this value. It's given to us. We just have to solve this value. Simple addition now. Net force, negative 27 newtons, is equal to force 1 of 48 newtons plus force 2. We flip this to the other side, so we end up with F2 being equal to, that works out to 75, or negative 75 newtons, which is forward. I'll write that on here too. This one was also forward. And if we want to give it some human qualities, something that people can understand, we can say that F2 is equal to 75 newtons. Oh, I should have said to the right rather than forward. Let's cross that out and say to the right. Right. And this is 75 newtons left. There we are. Final answer.